Very good morning, friends. I am going to solve the third problem in block friction. The problem, I want to define the problem. You can see the problem. There is a flow over this. I have a block. This block is having I can say this is a first block having the weight as 1290 Newton. And over this, I have another block. I can say this is a second block. This is having a weight of 570 Newton. In some problems, instead of this weight, direct weight, the problems will be given in mass, kg. Okay, you have to convert that into newtons. Okay, then you have to solve that problem. So here the weight of the block is directly given, and there is a wall. On this vertical wall, the second block is tied over this vertical block in an inclined fashion. So this slope, this is 3 by 4, 3 parts, and this is 4 parts. So I am pulling this first block to the right side. So what is this pulling force? If the mu between the blocks, mu blocks is 0.25, mu flow is 0.4. How do I find out this P? First of all, you have to find out the angle. So what is this angle? Theta. It is equivalent to this theta. So this is something like a triangle. We have already seen in many problems. So that triangle, if you see this theta, this is 3 by 4. So theta will be tan inverse of 3 by 4, which is nothing but 36.87 degrees. So the angle we have got. Now what I am going to do from this, I am going to terminate this thread, and there will be a tension acting in this. And I am going to investigate this problem into block by block. How to investigate this problem in block by block? The very first block, block 2, I am taking first. Block 2, if you consider, the block 2 will have a surface of contact that is from block 1 surface, and this is my block 2. This is having a weight of 0.5, which is having a weight of 570 newtons, and this block 2 is having a tension T like this with an inclination of 36.87 degrees. So this I am going to investigate first. So while investigating the block 2, first of all, so you can see you can draw the free body diagram. This block 2, while I am pushing the block 1 to the right side, there will be a relative movement of block 2 to the left side. So the movement of the block is left side. Relative movement with respect to block 1. So there will be a frictional force acting here on the right side. So what is that frictional force? It is having contact with the block. So mu block is 0.25 N1. 0.25 N1. N1 is from this flow. 0.25 N2. Block 2. We are having block 2. So I will be having a contact surface. This is block 2. I can have it N2. So this force, and I have a weight acting downwards. What is that weight? 570 Newton. And there will be a normal reaction acting upward. What is that? That is N2. So for this one, I will draw a free body diagram which is having upward force as N2, and I have to resolve this tension into two components, that is T cos 36.87 and T sin 36.87. So there is two components, vertical and horizontal components. So N2, and there will be T sin 36.87. The T sin 36.87 is 0.67. So I can write it plus 0.67 T. So this 0.67 is nothing but sin 36.87. 0.6, actually it is 0.67, and this T cos 36 point, actually it is 0.6, not 0.67, it is 0.6 T. Then T cos 36.67 on the left side, along with that, it is 0.8 T. And downward force is 570. And right side force is 0.25 N2. 0.25 N2. What else we have force? This force is added, shown, and N2 is shown, 570 is shown, minus 5. Okay. By using the equations of equilibrium, I can write two equations in this. This is equal to this, this is equal to this. That is, vertical component, both are equal. Horizontal component, both are equal. So 0.87 T, 0.8 T minus 0.25 N2 is equal to 0. There is one equation, I can write it. The another equation, 0.6 T plus N2 is equal to 570. I can write another equation. By solving these two equations, How many unknowns you have? This is T and N2. We have two unknowns, two equations we have. By solving this, I can find out T. T value is 150 Newton. N2 value is 480 Newtons. So this is the two outputs I have got from block 2. Coming to block 1, you carefully watch this. In block 1, it is having contact this block 1, it is having contact with both the surfaces. This block 1, on the floor, it is having a contact flow, and over this I have a block. That block is also having a contact with this block 2. What is the weight of the block? Weight of the block is 0.12. Weight of the block is 1290. And I have two contact surfaces, and I am pulling this in this direction P. So the movement of the block is this way, movement. So what I have to find out here is, while the block is moving right side, there will be two left side frictional forces will be acting. One is this and another one is here, because I have two contact surfaces. So this frictional surface is having a contact with the blocks, that is 0.25 N2. This is 0.4 N1. So how do I find out this 0.25 N2? N2 already you know, this 480. 0.25 N2, it will be 120. Right? N1 we don't know. And there will be a reaction here, that is N1. Here there will be a reaction N2 due to the contact surface. That N2 we know that N2 is 480. So this is the block 1 setup. So coming to this, I can draw a free body diagram for this block. I have P here. I have on the left side I have 120 plus 0.4 N1 plus 0.4 N1. On the downward direction, on the upward direction, I have N1. Upward direction, I have N1. And downward direction, I have 1290 plus N2. N2 value is 480. So by solving this, so I have a P, I have 0.25 N2 plus 0.4 N1, and I have N1 upward. There will be two loads, 1290 and N2. N2 is 480. So I have added. So I can find out from this equation, I can find out from this, I can find out N1 N1 is equal to 1290 plus 480. 1290 plus 480 is, it will be 1290 plus 480, it will be 1770 N1. By substituting this N1 to the second equation, that is P is equal to 120 plus 0.4 N1. We will substitute this N1 here. So I will get P is equal to 828 Newton. This is how we have to solve the problem. An overall picture of the problem is, so you have to take the problem by block. The first you have to solve the top block, that is the block 2, and you have to get the N1 value and the tension values. Then you have to go for the block 2, block 1. So that where you will be having two contact surfaces, so there will be two frictional forces comes into picture. When you can solve it, you can get the frictional value, that is the load value, as 828 Newton. Thank you.